Today we're going to be going over one of the most fundamental concepts in computer science, which is how to find an item in an already sorted list. We're going to be using problem 704 from LeetCode, the binary search problem. To kick off this video, I'm going to solve the problem cold. Feel free to roast me down in the comments below for how long it takes me to solve this problem. After solving the problem, we're going to go ahead and go over the key concepts of a binary search. Then we're going to go over the optimal code for how to write a binary search in Python. At the very end of the video, we're going to go over key takeaways for this particular coding problem and what you can carry forward with you into future coding problems. So let's go ahead and jump right into it. The timer starts now. The timer stops now. Today's episode of LeetCode Made Easy has made it very clear to all of us why we need to pseudocode before we write any real code in a LeetCode problem or a coding interview. We all just watched me spend about 20 minutes trying to debug a missing +1, whereas if at the beginning of my cold approach I'd just pseudocoded more or gone through a couple of examples, it would have been blatantly obvious that we needed that +1. So moving into the core idea of why we need a binary search. If you have a list of like 1,000,000 items, you don't want to do a linear search, because that would be O of 1,000,000 items in the worst case scenario. Whereas with a binary search, the runtime is always O log n, so it can get us a much better runtime if we have a sorted list of integers. Make sure it's a sorted list. If it's not a sorted list, binary search is not going to help you. So moving into what binary search actually is through an example. So if we have a list and our start pointer points to the beginning of the list and our end pointer points to the end, we have our middle pointer, which is start plus end, floor division 2. So in our case, if start is 0 and end is the end of the list, middle will be start plus end, floor division by 2. Now we're going to compare that middle pointer, or the middle value of nums at index m, we're going to compare that to the target. If it's equal to the target, we're going to return it. If it's less than the target, we're going to go to the right with middle. So we're going to set start to the middle +1. And if it's greater than the target, we're going to go to the left. Now let's take a closer look at that +1 and the floor division by 2. For example, if we have start at index 5 and end at index 6, when we add those two together, we get 11. 11 floor division by 2 is 5. Now, we don't want middle to be at 5 forever. We want it to be able to explore 6. So this is why we need our +1, because in cases like this, we're never going to be able to leave index 5, so it'll just end up being an infinite loop. Now, the reason why this works is because when we do this start equals middle +1, when we're going to the right, this cancels out needing to check for index 5. So now moving into the optimal code, this will make it all a little bit more clear. We can see here that when our current number equals the target, we're going to return it. When it's less than the target, we're going to go to the right +1. And when it's greater to the target, we're going to go to the left. Now we're just going to pause here on this code for a bit so you all can digest it. Now moving into our 3 key takeaways, starting with number 1, make sure you pseudocode out before you actually write code during a coding interview. Not pseudocoding out could actually cost you a job if you make a mistake or if it just takes longer for you to solve the particular problem. Moving into key takeaway number 2, and that is realizing that arrays are 0 indexed because of this man here, or at least that's what Google tells me. But arrays are 0 indexed, so if you're doing something where you need to manipulate the indices in an array, make sure that you're aware of this and you don't discount the index 0, which is the very start of the list. Moving into takeaway 3, and this one is so important. It would have saved me about 20 minutes of debugging, and that's making sure you run through a couple of practice examples with your algorithm before you actually try to code it out. I hope you found this video helpful and you can use it in future LeetCode problems. Thank you so much for watching.